Thank you again for joining us. We still have people coming in. This is Lessons, Lore, and Legacies of the 1992 Landers earthquake, 30 years ago today. And we're doing this in the evening. Of course, the earthquake actually happened early in the morning. My name is Mark Benthian. I'm the Director for Communication, Education, and Outreach at the Southern California Earthquake Center based at USC. And we are an earthquake science research center with funding mostly from the National Science Foundation and the US Geological Survey. And the USGS is a partner in today's webinar, as they are in much of the work that we do. Our agenda is to hear from Dr. Susan Huff with the US Geological Survey about the earthquake and the lessons learned at that time. We're also going to hear about the emergency response lessons and then and since from Division Chief James Topolesky with the San Bernardino County Fire Department. We're then going to hear some local perspectives from people who were living in the area at the time and have a few different stories. At that time, we're also going to invite all of you, if you have stories, that to put those into the Q&A. We may call on a few of you to share those stories with everyone. So we'll remind you about that at that time. And then we're going to conclude with another science presentation from Professor Greg LaRosa at Stanford University, who's also co-director of the Southern California Earthquake Center, talking about 30 years of earthquake science, the legacies of the Landers earthquake. So to begin, we're going to introduce Dr. Susan Huff with the US Geological Survey, and Sue, I will advance your slides.
Great, thank you so much, Mark. It's an honor to kick things off. I want to start with a shout out to Mark and to Gabby Noriega for really doing the heavy lifting to organize this webinar and to arrange for the lineup of speakers. I'm really looking forward to hearing from the later speakers about their experiences during this earthquake sequence. So next slide, please. If you were in the area 30 years ago, you know that the Landers sequence really started a couple of months earlier with the Joshua Tree earthquake on April 22nd. Down when there's a star to indicate where that earthquake happened, it was a magnitude 6.1. You might hear me talk about the 22nd or the 23rd because that earthquake happened late in the day. It was April 22nd according to local time, but scientists used UTC or GMT, basically the time in London, and it was already the 23rd by the time the earthquake happened. So it was a moderately large earthquake out in the desert. Next slide. It was not a huge event. It caused some damage if you were in the area. The shaking would have been quite strong. But I went back and found an article from the Los Angeles Times talking about rattled nerves as the impact of this event. So a magnitude 6 in the desert isn't a hugely impactful earthquake in Southern California. Next slide. But this earthquake caught the attention of the scientific community more than just a generic magnitude 6 in the desert because of its proximity to the San Andreas Fault. So before I get to that, just to explain my own involvement with the sequence, I started at the USGS in Pasadena, March 1st, 1992. So Joshua Tree happened just less than 2 months later. I felt that earthquake. I was part of the response. I led a deployment of instruments, including a dense array in Morongo Valley. On June 23rd, so those instruments recorded aftershocks. The aftershocks died down. June 23rd, I went back to Columbia University for a student exam. The 27th, I flew back to California, and then I was awakened on the morning of the 28th, along with, I assume, all of the rest of Southern California by very powerful shaking. So next slide, and I'll get back to that throughout talk. Well, so the earthquake, the Joshua Tree earthquake caught people's attention, scientists' attention, because it had struck quite close to the San Andreas fault. And I'm not sure how much press this got at the time, but there was actually what was called then a level B alert that was called indicating a evaluated 5 to 25% chance of a larger earthquake on the San Andreas fault within the next few days. So the concern was that Joshua Tree may have been a foreshock to a major San Andreas earthquake. In retrospect, scientists would look back at this forecast and it was naive. We have a better understanding of probabilities now, but the fact remains that there was concern. Next slide. So that level of concern, the location of the event, sparked more of a response than there might otherwise have been. So there was a seismic network at the time that was recording a lot of data, the main shock and the aftershocks. Part of the response was to go install additional instrumentation, and this is the type of instruments that my team was installing at the time. They had magnetic tape recording, if people remember that. Geologists went out to look for signs of surface rupture. So when an earthquake happens, earthquakes happen at depth in the fault, and they have to be a certain size to break to the surface. Magnitude 6, 6.1 may have surface rupture, it may not. This earthquake did not. Next slide. So I'm aiming to go through things fairly quickly, so we have plenty of time for the rest of the program. So then again, as we all know, 4:57 a.m., June 28th, a bigger earthquake did happen, not on the San Andreas, but starting near the small town of Landers in the desert, and then rupturing mostly towards the north. It left a dramatic, this earthquake did break to the surface at 7.3. We expect there to be a surface break, and this earthquake did in fact leave this dramatic scar. Next slide. So when an earthquake, the earthquake primarily ruptured laterally. So if you have a fault that moves sideways through the desert, you may not necessarily see the offset easily because you're just moving desert sideways. But where you had fences or roads, you could see that the fault had moved things sideways. There were a few locations where the rupture, the break actually moved things a little bit vertically as well. And so that creates a much more dramatic feature that you can see when part of the fault moves vertically relative to the other. Next slide. So I wanted to touch on a few of the scientific lessons that came out of this earthquake. This earthquake shook up Southern California, and it really did shake up earthquake science in some very important ways, as I indicated with the bullets here, and I'll go through them in more detail. It taught us a lot about the complexity of how earthquakes influence other earthquakes, including the identification of remotely triggered earthquakes, and I'll explain all of this. And then it taught us a lot about the complexity of earthquake ruptures themselves. So next slide, please. So this is sort of the simple cartoon about earthquake sequences. On the bottom, it's a timeline of earthquakes. It shows the lollipops for the magnitude of earthquakes going through time. So you might have, I don't know if my cursor is going to show up. Sometimes they don't. No, probably they won't because you're not seeing my screen. Okay, thank you. So you may have an earthquake and then some amount of time and then another earthquake and then a bigger earthquake and then littler earthquakes. And by convention, thank you, Mark. By convention, we call those initial earthquakes foreshocks. We call the biggest earthquake a main shock, and then we call the littlest of the smaller earthquakes afterwards, we call those aftershocks. That really is a matter of convention. And one important point is when that first earthquake happens, there's nothing that tells us specifically that it's a foreshock. It looks like any other earthquake of that magnitude. We've known, even before 92, we knew that this cartoon was really too simple, that earthquake sequences don't always fit neatly into this taxonomy. But Landers really hammered that lesson home. So the next slide, and talk a little bit about the complexity of the sequence and what it illustrated. So yes, we had the Joshua Tree earthquake in April, and then it had a lot of aftershocks, quite a few. If you were in the area, I'm sure you felt a lot of them. And then the Landers earthquake farther north. So Joshua Tree aftershocks died down, and then you had Landers. It had its aftershocks. Oops, I think we may have gone forward, but what this, I don't know if it's worth trying to go back or not. Yeah, there we go. So what this really illustrated is that it isn't really a simple matter of foreshock, main shock, aftershocks. It physically, any earthquake should be considered a parent event that can have daughters or sons, if you will. It can trigger other earthquakes. Usually those daughters are smaller, but they can sometimes be bigger than the parent. So you can get these complicated sequences as we saw here. So what we called the Joshua Tree earthquake or main shock, in retrospect, we consider it a foreshock. Okay, next slide. Another lesson was that, which we knew, was that big earthquakes can have big aftershocks. As a rule of thumb, the largest aftershock will be about 1 magnitude unit smaller than a main shock. Big Bear was close to that, 6.3 to 6.5. But it was a big event in its own right. It was no different than from a magnitude 6.3 independent earthquake. It felt stronger to a lot of people because it was closer to some of the major population centers. And another thing that Landers illustrated was that aftershocks are not necessarily on the faults or the faults that moved in the initial earthquake. They're in proximity to the main shock, but they can be some distance removed. So next slide.
I'm sorry to interrupt. The ASL interpreter Liz needs to be spotlighted, please.
Oh. Yeah, I'm not, did we lose him? There, okay. I see Liz. Okay. So next slide. So some of the work that was done after Landers involved looking at how aftershocks are triggered and what processes control the locations of aftershocks. And so next slide. So when earthquakes happen, you are moving big blocks of the Earth's crust around. Fundamentally, whoops, we skipped one. Fundamentally, an earthquake releases stress. And we're going to, if we can get back to the previous slide, there are figures like this were generated by a number of scientists. The purple blobs show where stress is released by Landers, but you also increase stress in other areas off the ends of faults. And then because of the geometry of Landers, you had a stress increase off to the side, and that was associated with the occurrence of the Big Bear earthquake. So we learned a lot about why aftershocks happen and where they happen. Next slide. Not only that, but Landers led to the first recognition of a new class of earthquakes called remotely triggered earthquakes. So aftershocks cluster in proximity to a main shock where the stresses are increased. And then if we can go to the next slide. When an earthquake happens, you move blocks of crust around, but you also send powerful waves into the crust, which we feel, but it shakes up other faults. And that, what we call dynamic stress, turns out that can cause additional earthquakes to happen. And let's see if the slides. Next slide. Okay, whoops. I think there's a delay so that it takes a minute for the slide to come up. So it's a picture that shows how earthquake rates increased not only in proximity to where landers had happened, but the state of California really lit up like a Christmas tree. And it was clear that earthquakes had been triggered 1,000 kilometers or more. Those earthquakes are associated not with that kind of stress that I mentioned, but with the seismic waves themselves. Maybe we should stay on this slide while we're here and not try to go back. Another lesson from landers had to do with the complexity of an earthquake once it gets going. So when the fault starts to move and the rupture gets going, then what happens? As of 1992, there had been quite an active debate about what size earthquakes are possible on complicated fault systems. So if you look at the Mojave, there are a lot of faults that were mapped as individual structures. They peter out, and then there's another fault after some gap or offset. And there was debate about the maximum size of an earthquake that was possible on faults like this. So fundamentally, magnitude reflects the size of the fault that moved in an earthquake. If a fault is only 20 kilometers long, that limits and an earthquake is limited to 20 kilometers, that limits the magnitude. The landers blasted through, it ignored the separations that geologists had mapped. It jumped, it continued on 5 different faults that had been mapped as separate structures and a number of minor faults. And this had important immediate implications for seismic hazard assessment, understanding what earthquakes are possible on different faults. Next slide. And then the last lessons that I want to highlight have to do with the complexity of the plate boundary here in California. Oh, no, I skipped over something. Next slide. I think the presentation went away.
Do I apologize? I've actually been like, my computer has been frozen this entire time, and I've just now resolved it. And so just give me one moment. I'm going to reshare screens again.
Okay, I think I'm running a little longer than I wanted to. So let me just let me just keep going and try to wrap this up so we have plenty of time for the rest of the program. So there was a tail of the surface rupture to the south on the Eureka Peak Fault. Those instruments that were in Morongo Valley were key to understanding that little tail of surface rupture to the south happened during early aftershocks, not during the main shocks. So that was another example of complexity. And then the lander sequence died down. 1999, the Mojave sprang to life again with the Hector Mine earthquake. So I think we can jump forward 2 slides, or 2 more. So we had another magnitude 7 out in the desert, mostly to the east of where landers had struck. And then next slide, as many people know and felt, just a couple years ago, we had the Ridge Crest earthquakes. And I really like this image, which Egil Haugson put together after landers. It shows the San Andreas Fault running along, which we know is the primary plate boundary fault. But then there's a series of faults in Eastern California, which we call the Eastern California Shear Zone. And so we know the North American plate is moving mostly sideways relative to the Pacific plate. The plate boundary isn't a simple cartoon knife edge. The plate motion is really shearing California into ribbons. There's important faults along this Eastern California shear zone. And as it happens, we haven't seen major earthquakes on the San Andreas since the 19th century, but as it happens, the Mojave and then continuing up to the north has been active in recent times. It's interesting to look at this figure, and we all want to know what's going to come next, and seismologists don't know. There is a gap between the Landers earthquake and Ridgecrest Now, could you have another earthquake there? Certainly. Why did activity jump all the way up to Ridgecrest? We don't know. Maybe there were earthquakes in this gap in relatively recent prehistoric times. Eventually, we know that the San Andreas, which has been quite quiet, it's not going to stay quiet forever. So the last note I wanted to end on is concerns the USGS Did You Feel It system, which hopefully you know is, oh no, so there's I wanted to summarize the lessons from Landers. The key word is really complexity. It taught us so much about the complexity of earthquake ruptures, of how earthquakes influence one another, at protracted sequences, and the complexity of the plate boundary in general. And some work is still continuing along these lines. I think Greg Barossa will talk about some of that. So lastly, the Did You Feel It system, so the USGS developed the Did You Feel It system in 1999, so that was after Landers. If we can go to the last slide, you can go back and contribute you can fill out a questionnaire retroactively and report in what you felt. Be careful to note where you were at the time, not where you are now. As of today, there were about 600 responses to this earthquake, and that builds up a map of how Southern California shook. So if you felt the earthquake, and if you haven't done it yet, I'd like to encourage you to report in and to add your own observations to this map. So with that, I'd like to thank everyone. I know there's a lot going on in the world, so thank you for tuning in.
Okay, and sorry about the technical issues. I've never had that happen before, the way that it froze on everything, yet still kept working to a certain extent. So if you have questions and want to go back to see anything, we can do that now. We do have in the Q&A, someone asked, could we see the amplitude graph of the Landers earthquakes? So maybe that was something we didn't see, or was that just referring to this one?
No, I think it was may have been the seismograms, but I'm a little worried about time. I don't want to.
We're okay. We're okay. So just
okay.
Any other comments in the chat of anything that, or again, put your question for Sue in the Q&A if you have any right now. Otherwise, we can move on. There is a question in the chat, though we do prefer Q&A. Was the integration affected by the Landers quake? So does question, do you understand that question, Sue?
I'm not sure I understand what's being asked.
So Arlene, if you could maybe add more to your question there, and we can answer that.
Oh, it's a building in Landers. You know, there was damage in Landers. I didn't include any slides. There was quite severe shaking.
Excuse me. The Integratron didn't suffer any damage from the earthquake.
Excellent.
Okay, great.
Thank you. One of our panelists who lives out in the area knew the answer. Thank you. Okay, so any other questions? We have comments here in the chat. Eldon Gath, Sue, do you really consider the Big Bear event an aftershock, or isn't it a triggered event? What's the difference?
Well, this does, you know, it's largely by convention, but I think
it's largely by convention, but I think anything.
Now I'm hearing an echo of myself. That's really annoying.
Now I'm hearing.
By convention, it's considered an aftershock. That the static stress change is significant within sort of a certain distance from a fault, and Big Bear was within that distance. So where these static stress changes are thought to be important, but there's a whole lot of details that I'm not able to get into. There's been quite a bit of debate, as the questioner I think may know, that about, can we be sure events were aftershocks versus triggered earthquakes? And a lot of times the answer is no. But I think seismologists would say that Big Bear was an aftershock. This is kind of exciting with all the IT.
There's also a question for Brian Olson. The Joshua Tree was south of the Pinto Mountain Fault. Do you think there is a subsurface through-going fault, or did the shaking increase stress across the Pinto Mountain Fault?
Hi, Brian. That's a really good question. So I didn't mention the Pinto Mountain Fault, but Southern California, there's all these faults that kind of line up in the same direction. And then there are these faults that run across. The Pinto Mountain, as Brian knows, is one of them. So Josh, that the Pinto Mountain was a structural boundary that between Joshua Tree and Landers. But it's you have plate boundary faults that are moving sideways. And then you have crosswise faults as well. And exactly how those systems work and evolve over the long term, I think, is a really good question. Brian may understand the answer better than I do. So I see a question about INSAR. Landers, I didn't talk about it, but Landers was the advent of what you could call geology from space, in the sense that satellite data were used for the first time to map out the breaks in the desert through the development of what we call an interferogram. I don't have a slide to show that.
So one last question on the Did You Feel It forms. Do you know, is there an app available, or is it just through the web page?
It is browser-based, which makes it a little difficult to use on a phone because the questionnaire gets quite small. Yeah,
But definitely you can just Google Did You Feel It to find the form. And you can look back at past events to find Landers and share your experiences. You remember it from then. Okay.
or you can, thank you.
Anything else, Sue?
Thank you.
Okay, so again, sorry for these technical issues. Let's go to our next presenter, who is Division Chief James Topoleski with the San Bernardino County Fire Department, who will share what he was doing at the time and his experience since.
Good evening, all. I'm honestly in New Mexico right now, working in their emergency operations center, following the large fires, and now planning for flood events with the monsoonal flow coming in. So this presentation or this discussion brings up many good points as first responders or preparedness agencies, how we prepare for earthquakes, wildfires, or anything along those lines, because there's honestly quite a few parallels between all of the natural disaster events or man-made events that require a significant resource commitment. That being said, I'm then the fortunate or unfortunate person to be providing this presentation. I think it came down to, does anyone remember or was working at the time of the Landers earthquake? And I was a young firefighter. I was working in the valley when the Landers earthquake struck. We had had an extremely busy night that night, running medical aids and some fires. And then the earthquake struck and it changed the entire tempo. We were in a two-story building built in 1948, and we all thought the building was going to come down on us. So that was kind of the trigger in the Valley response event, which eventually led to the Landers response that we responded to. And next slide, please. There you go. Okay, so the historical perspective from the fire response or emergency response services is we were not well prepared. While we had the best of intentions, urban search and rescue concepts were very limited. The fire service is typically a service that always strives for funding or to maintain funding. And when the next best thing comes about, it takes a while for it to really entrench into the organizations to where funding streams becomes sustainable. So we were at the cusp or the crest of USAR was being developed. It wasn't really a full-fledged event, and honestly, the staffing and the equipment that's required for that was really poor at that time. So over the past 30 years, there has been a significant change in that, and in the following slides, we'll talk to that. During the earthquake, there was a lot of confusion. Radio systems went down. We did not hear a lot of information coming out. Most things, we rely on the news to provide live updates, and it was going to take some time for the LA-based news media to make it all the way to Landers. So we were kind of all in the blind working that day. When the Big Bear earthquake or aftershock hit, it woke the valley up and things really started to begin to move and mobilize, not only for the Big Bear event, but also in Landers. It just took a bit for the system to catch up to the problem. The Big Bear earthquake caused us some issues in that obtaining resources or responding to areas that were affected was proving to be a little bit problematic. Obviously, Highway 330, 18, and 38 had rock slides or were impacted where we couldn't move up and down. The water systems, especially in Landers, and I'll talk to that a little bit, and that's why I went as a firefighter to Landers, was because the water system impacts, and they were extremely worried that structure fires would continue or would erupt, or vegetation fires would start, and they had no capacity to fill fire apparatus to provide that. And as I spoke a little bit about it already, there were specialized personnel, but the resources were extremely limited, as were the personnel that really understood building shoring, collapse, and things of that sort. So next slide, please. So the lessons learned is these are the modern day resources we kind of come out with. Back in 1992, these were not in existence. The training was limited and the apparatus that we drove is extremely limited. In fact, I left the Valley on a 1952 military 6x6 that had a water tank on it. And it was quite the treat driving the 70 miles from the Inland Empire out to Landers with no air conditioning in the middle of a hot late spring day. So San Bernardino County fires, since this earthquake and others along the way, we have brought about and created a USAR task force. And the USAR task force is comprised of specialists in trench rescue, building collapse, high angle type systems. So San Bernardino County is proud to field one of the regional task forces as a USAR. So that's a real positive change. Another positive change was the communication system improvements. There's additional redundancy, obviously with cell phones now, which were not really prolific in the area at that, or in everyone's hands at that time. That helps, but it also hinders just due to the taxing of the system. So our communication system has been beefed up and significantly more robust, and it gives us quite a bit of additional capacity as far as command and coordination. As I mentioned, water was a problem. We brought in large, at that time, water tenders. As you can see in the upper right corner, there was, that's a modern water tender that we have now. And so we brought many of those types, or 5 of those vehicles from the Valley out into Landers to support the emergency. The emergency command support was extremely lacking out there. and within the county at that time. While everybody had great intentions, the focus of the fire service back then was emergency medical services and fire response. That has since changed. We consider ourselves what is termed as an all risk. In essence, we do everything. So if you have if we have an earthquake issue, building collapses and things of that sort, I can talk to them. I know it's on the slide, so it's fine. We have a significantly greater resource capacity now. And the San Bernardino County Fire Department does employ a fleet, not with 2 bulldozers, an excavator, front end loaders, and some smaller heavy types of pieces of equipment to not only help on fires, but also to help in the event that something of this magnitude happened. Next slide, please. Okay. So somehow that slide got a little corrupted, but it's fine. It really comes down to preparedness, either as a civilian or as a governmental agency. As I mentioned, we drove out into the desert. We were staged at the Landers station, and there was no support. There was no food. There was no drinking water per se, other than what we brought. There was no shade. We provided our own shade. So for the numerous days that we were out there, we were pretty rustic in how we survived. But at that time, that was what was expected. So now what we really want to push and what we try to communicate is we are in a state, California is a unique state. We're in a state that is replete with natural emergency occurrences, whether it's wildfires, earthquakes, or floods. California is constantly faced with these types of emergencies. From the government side, that's amazing because we have our first responders and our command and control staff have an incredible experience level just due to they do a lot of this. As I just mentioned, I'm in New Mexico at the time, helping New Mexico out. So we have quite a bit of experience in managing these types of incidents. The other side to it is the resiliency, and this applies not only to the fire service or government services, but also more importantly to the citizenry. If you do not have a plan that's going to sustain you for 72 hours, you need to really develop one. And that's a real critical aspect, is whether it's a public or a power safety shutdown or the PSPSs that the power companies put out. If you cannot survive comfortably for 72 hours with food and water, you're going to have a lot of problems. The emergency responders can't get to you quickly. When you take a look at how the resources San Bernardino County has, we have 48 fire stations, which means essentially 48 fire crews, as with the other local jurisdictions that are surround or make up the county. Everyone on an earthquake is going to have significant problems. So a really robust response where for every problem you have, the government or the fire service is going to show up and to help you solve it. It's going to take us a while on a large scale event, very similar to what occurred in Landers. It's going to take us a while to get to every need. So having food, water, shelter for 72 hours requires planning, preparedness, but most importantly, a mindset. You have to have a mindset that I'm going to survive. I'm going to make it through this. We only have to really rely for 72 hours before outside aid comes in. That's pretty much sums up my presentation. I'm happy to take questions. Anything that the county fire department can do to alleviate some of your stress or concern, please do not hesitate to reach out to us. We're very engaged and active within our communities within the county.
Chief Topolewski, thank you very much for your presentation. And we do have a couple of moments for any questions. Please, if possible, put them into the Q&A tool. We'll take them from CERT 2. I'll take the one, but do look also in the Q&A section for answered questions that have been asked but responded to by type, in written answers. So you can look for some of those there. We will take a question. Jeff Warhol asks, Do you feel a CERT program can be of benefit resource in assisting post-quake? That stands for
Most
Emergency Response Team Program. Yeah, go ahead.
Most definitely. The concept of neighbor helping or community helping community members is going to be critical. As I mentioned, we have a very large fire department, but we also serve the largest county in the continental United States. So there's needs everywhere, and if you contemplate where Landers is and you need help, it's going to be coming largely out of the valley area, and if road systems are down, they're compromised. So the reliance on a CERT program or CERT members is critical. One, CERT members have they have training more so than the average person, and know where to turn off the natural gas or propane systems. When the earth shifts, so do those pipes. So having those members there to help bring calm and peace to people that, their nerves are rattled. I know I was rattled out there for the 4 or 5 days that we were there every time an aftershock struck. So yes, CERT members are extremely valuable.
Also a question that's related to this slide. Someone is asking, who sells a good tent with reflection exterior to stay as cool? Does anybody, do you happen to know where those would get? I imagine you could probably look on Amazon or other places to find such tents.
So that tent, I will tell you, I grabbed that one because I don't have one at my house. I just have regular camping tents. That tent, though, there's firefighters when we travel around the United States and we live out of a tent. That's a tent known, and this is not an endorsement of that company. I'm just telling you personal experience with that tent. It's an amazing tent, and it's made by a company called Shift Pod. It's pretty cool. I would recommend that tent for the home. But again, I'm not representing it. I'm just giving you an opinion.
Okay. Eric Morgan asks, I'm wondering if you are considering utilizing help from the private sector in response. For example, Team Rubicon, if you're familiar with them.
If I'm correct, is Team Rubicon the off-road for Jeep club? If it is,
no, it's a response organization that helps with a lot of disasters around the country and is growing, and perhaps international too. But just generally, the idea of private sector support, maybe even faith-based and other groups that do a lot of post-earthquake and disaster support.
Absolutely.
Their role.
Yeah, absolutely. The critical part to any of those private entities or community-based groups is coordination. To maximize the resources or create a force multiplier, coordinating with the incident command or the command and control of the incident is critical. But we take that type of assistance quite readily on many disasters. And that's not to say we're going to do it on every single one. Each emergency has its own uniqueness. In regards to contractors and private entities, when we're looking for heavy equipment or things to procure to support the operations that we're conducting, yes, we do rely on private companies, but we do sign them up via contracts to make sure if they're one of the companies that we're going to bring on for payment.
And then very quickly, we have a thank you to firefighters and other first responders. So thank you, Sue Changes, for that. And then finally, earthquakes ignore man-made boundaries. Do fire departments co-plan or co-train with adjoining counties? Really quick answer.
Yeah, the USAR teams definitely do. If you're in a department that borders say an opposing or adjacent county, we typically train with those agencies. The great part to California, it's the father or the birthplace of the incident command system and the mutual aid system. As I mentioned, I'm here in New Mexico helping New Mexico out. So the fire service is a very fluid and dynamic organization as a whole, where we go and assist other agencies. We train essentially all on the same things. We put water on fires, and certain books that teach you to do that, or academies, and they're all based on very structured and collaborative type training programs that help firefighters be in the same spot.
Chief Topolowski, thank you again for your presentation and answering these questions. Please stay around. We may have more questions later on. Next up, we'll move to some local perspectives. And as I said at the beginning, if anyone who's joined us wants to add a comment or two, we'll call on you, but you, please put your comment into the Q&A for us to do that. You can just put it into the chat just for everybody to read, but in terms of coming on live to share your story, you'll need to go into the Q&A. It looks like one of our presenters wasn't able to join us, so we'll start with Chris Gubler of Gubler Orchards, and we'll bring you on, Chris, and to share what happened to you and your company back in 1992.
Well, 30 years ago, my life was turned upside down. Talking about emergency services, the number one thing was we had a volunteer fire department out here, and they were in dire need to send people somewhere. And at the time, we were not earthquake prepared, but you start making mental notes on what to do so you're prepared if another one should occur. For example, you know, there was a 210,000 gallon water tank on Landers Lane that looked like a crumpled beer can. The weight of that thing was 1,700,000 pounds, and it bounced like a soda can. And you start making a list. We had a 10,000 gallon water tank that moved 5 feet and broke all the 4-inch water fittings, so we didn't have water. The other thing we don't discuss is, you know, we're all on wells out here, the water company, individuals, and when you have an earthquake that large, the pump that goes into the casing clangs against the casing, and it can jam the impellers in these parts called the bowls, which pushes the water up. We lost a well to that clanging inside the casing, but thankfully we had another well that operated. The main thing that we can tell you is that the greenhouses shook so much that it was a hydroponic facility at the time, and the land went up 8 inches, so the hydroponics didn't work anymore because the greenhouses weren't level. The lateral side supports that are for earthquake protection, they worked for the most part, but some of those broke free, not from the weld, but from the base material, to give you an idea of how strong this was. The cement was all broken up inside our nursery. We didn't allow any interviews because we had to control the story. You know, we shipped all over the place, Canada, Japan. We didn't want people seeing us on the news saying, oh, poor Gubler Orchids, we'll have to find a new company. So we controlled the story, and I very rarely talk about it, but being prepared, simple things at home, turn off your gas, shut down your hot water heater because there's 30 gallons of water in there. If you're saving water, rotate it every 6 months so that you have water. The number one thing that I am thankful for about this earthquake was it happened here. And if this magnitude would have happened in Northridge, can you imagine the devastation that really would have occurred? So, we started making a checklist so we have all the fittings should another earthquake happen so we can get the water system going. We have an upgraded generator so that if an event were happening, we can supply comfort to those that don't have a tent, provided the building's still up, of course. But, we had power, we had water within 24 hours. And, to see the roads shift, about 11 feet, what was a straight road is now a crooked road. No one knows the difference. It was quite dramatic. And of course, your adrenaline is going full tilt because you haven't heard anything like it, and you certainly haven't felt anything like it. And when I looked outside my home, you could see the dust coming from the Big Bear area. and from Goat Mountain, which is to the east of where I live, just these big plumes of dust. And so, you know, you never know when it's going to happen, and everything you've worked for can be taken away in less than a minute. So be prepared.
Chris,
I don't know how to
really,
my head.
really fantastic comments and advice. I'm very inspired by you being thankful that it happened to you and not to in a more populated area. That's not something you normally hear people say, but I appreciate your the reasons why you said that, and also for sharing your story here. So thank you again. We will now move to Gino Prudhomme.
Can I make one last comment?
Oh, sure, of
please?
course. Go ahead.
Gary Denio, who was supposed to be on the panel today, you know, his radio station was the lifeline for information during this whole event.
Right.
And they did a tremendous job. And it illustrates the point of having a working radio for a local broadcasting station so that you're kept up to date.
Chris, thank you for adding in his story. That we definitely wanted to hear that because of the value of that. We know at the time that it was pre-internet and pre-cell phone, and the local radio station definitely was as you said, a lifeline of information. Okay, we will now turn to Gino Prudhomme, and who also a resident of the area at the time, Gino, go ahead.
Okay, I want to start by thanking Miss Marjorie Smith for all of her hard work in our community. She works as the director of the Morongo Basin COAD and spends countless hours helping our community become more aware and trained for disasters in our area. Marjorie and I have served together for several years in a public affairs setting throughout our church, the Church of Jesus Christ of Latter-day Saints. And one of the aspects of our public affairs committee has been disaster preparedness. With me being an ecclesiastical leader for many years, I've had many opportunities to speak and train our church members about preparedness. And Marjorie heard my story many times about the Landers quake and referred me to talk to Mr. Bithium, and I appreciate Mark for inviting me to share my experiences, so that's why I'm here. Before I go into specifics, I want to give you a little back history of leading up to the Landers quake. Prior to the earthquake, outside my professional career, I was a volunteer as a Boy Scout leader in the Boy Scouts of America, and our church sponsored the Troop 180 here in Yucca Valley. A few weeks before, leading up to the earthquake, we as a scout troop wanted to find a way to raise money for our scouts to go to scout camp. And since our church has always encouraged self-reliance and emergency preparedness, we thought it'd be a great fundraiser to sell water barrels to the community to help residents store water in the use in the event of an emergency. Through my research, I found a source for barely used food grade 55-gallon barrels, which we purchased through the Sunkist Corporation. And I purchased 50 of those initially. In anticipation of our upcoming fundraiser, I stored these barrels in my garage. Now, in my professional career, I worked for an underground utilities company. And at that time, we had a contract with East Valley Water District in Highland, California, to do all their major water line repairs and repiping throughout the Highland area.
Gino,
Fast forward
hold on a second. Is another person trying to control the spotlights? I think we're fighting each other. Just if you can let me control it, please. Okay, go ahead, Gino.
You bet. Fast forward to Saturday night, Saturday, June 27th, 92, the night before the earthquake. During that particular night, me and several coworkers were performing an emergency water main repair on Baseline Avenue near Church Street in Highland about 8 p.m. that night. And we were about 10 feet deep inside a trench making that repair. And I made a comment to my coworker. I said, it would really stink if we had an earthquake right now. And my coworker kind of chuckled. He says, that's not funny. And so we finished repair about 10 p.m. and I headed home to Yucca Valley. During my drive home, I got several strong impressions that I should fill up a couple of those water barrels that I had in my garage. When I got home, still ignoring those impressions, I showered, got a bite to eat, kissed my daughter, my wife goodnight, and went to bed. Lo and behold, that next morning at 4:57, we were all rocked by that June 28th Landers quake. Through the shaking and trembling of the quake, my wife and I managed to get out of our waterbed, grab our daughter from her crib and run outside. It was pretty terrifying for all of us, and our nerves were pretty rattled. Through all of the aftershocks, I began to inspect the damages. Everything seemed to be intact for the most part, with the exception of a few new cracks in our stucco at our home. But through deeper inspections, I noticed we did not have any running water. That was a moment I felt much regret for not listening to those promptings. Once things started to settle down, I contacted a good friend who lived in Joshua Tree to see if he had water, and he did. So he graciously invited me to come over and fill up 2 of those water barrels that I had in my garage. And our surprise, and this is one of the things, 55 gallons of water didn't last very long when you're using the water to drink, to cook, to bathe, and to flush toilets. And we were out of water for a total of 25 days. During those 25 days, I made multiple trips to fill up water barrels. Just like Chief Topoleski said, we were not prepared. And those experiences we endured during that earthquake caused me to really change my way of thinking and become, as the Boy Scout motto it says, is be prepared. And be prepared for any and all disasters that may come our way. We all need to become self-reliant in the event of an emergency. Like Chief said, we may not have access to emergency services. We're going to be on our own for a bit. So we need to make sure we do that. We've all heard the saying, fail to plan, plan to fail. And I took that experience and went into action and began to plan. That event helped me be an instrument in putting together disaster plans for our church here in the local area in Yucca Valley, 29 Palms, Desert Hot Springs, and Palm Springs. And through all of our ecclesiastical leaders now, each and every one of us, we ask that we get a ham radio license. And we've all implemented plans within our congregations in the event of emergency. Fast forward to 2006, we had the Sawtooth fires. And I was able to, I served as a bishop at the time, I was able to implement that plan, and it worked really well. As Chris Bubler said, I'm grateful for the opportunities and the experiences that I had and the experience that I had with that earthquake. And through that experience, I've been able to better prepare myself, my family, my neighbors, our church, and our community. And I'm honored to have been given the opportunity to share my experiences with you on this historical anniversary. Thank you.
Gino, thank you very much for not only sharing your story at the time, but how it inspired the preparedness actions you've taken since, and really encourage others to do so too. So it's really a message that for all of us on the webinar today to be paying attention to, and be looking at how we can be learning and doing more. For the sake of time, doesn't look like we are going to be able to take any further stories, but in the chat, just FYI, I did put a link that someone found for that reflective tent, so you can find that in the chat, also in the Q&A. And we have had some discussion going on in the chat for some of the science that we're going to now switch back to with presentation from our final presenter. And this is, I'd like to introduce Dr. Gregory Baroza from Stanford University. So we'll just get Greg, you on camera and back and ready to go here.
All right.
Add you to the spotlight. Hopefully everything will go smoother than earlier as the connection is better. Sorry,
yeah, let's see.
Sue, and it's just kind of like a Murphy's Law type of afternoon here. So go ahead, Greg.
Yeah, thank you, Mark. So first, thanks to all the previous speakers for their recollections and insights. It's been really fascinating to listen to. I'm going to try to recount some of the scientific legacy of the Landers earthquake. I can't do it comprehensively, and I'm going to build very much on the material that Sue Huff presented in the first presentation, where she made the case that the Landers earthquake was a landmark event that really changed the course of earthquake science. And I'll try to illustrate that the findings from that earthquake continue to inform how we do earthquake research, not just for that earthquake, but for other earthquakes. So next slide, please. One of the things that Sue emphasized was that the rupture was complicated. So this is a sort of rotated view of the fault shown in the panel on the upper left. The earthquake started at the epicenter where that circle is. It ruptured on the Johnson Valley Fault, skipped over a fault discontinuity onto the Homestead Valley Fault, and then ruptured through another discontinuity onto the Camp Rock and Emerson faults. And as Sue mentioned also, that there were some other faults that were somewhat involved. So geologists had named these faults differently, but the earthquake really didn't care about that. It just ruptured where the conditions were ripe for the rupture to continue propagating. And this understanding that segmentation isn't the only control on the maximum earthquake size was something that had been debated, and the Landers earthquake provided irrefutable evidence of multi-fault ruptures. And that's been a very important finding for our efforts to do long-term earthquake forecasting. So next slide, please. A more recent and even more complex example than Landers was the 2016 Kaikoura, New Zealand earthquake. This earthquake ruptured at least 12 large faults. Those faults had different orientations. They're shown in the panel there with the straight black or curved, sometimes curved black lines, different orientations and different slip directions. So this theme of earthquake complexity that was highlighted by Landers has been emphasized since then by other earthquakes as well. Next slide, please. Okay, so what impact has this had on the field? So here's an important example. This is from the Uniform California Earthquake Rupture Forecast version 3. It's a long-term earthquake forecast model for California. What's shown in those bright colors are the participation rates of the different faults that we're aware of in California. And if you'll notice, there's maybe you can see the white box that's centered on metropolitan, greater Los Angeles. That's of particular interest because of the high risk exposure from earthquakes that occur there. Shown in the upper right is a summary of the expected earthquakes over the long term within that box. So the red curve, or the red curves, there's an uncertainty bands there too, show the previous rupture forecast, and the blue curve shows the current or the updated rupture forecast. What's shown on the x-axis is the magnitude, and what's shown on the y-axis on a logarithmic scale is the cumulative rate per year. So note that between magnitude 6.2 and 7.2, there's a bump on the red curve relative to the blue curve. Now that might not seem like much of a difference, but it's quite significant because this is a logarithmic scale. So the previous forecast had several times as many of these large, pretty large and damaging earthquakes occurring as our current forecast. We think the blue curve is better, and it accounts for the possibility of multi-fault ruptures and earthquakes within that white box. So here's an example where Landers has made a difference in our interpretation of earthquake hazards. These forecasts are used for many purposes, including the building code and setting insurance rates in California. Next slide, please. Sue noted this remotely triggered seismicity. That was another thing that the Landers earthquake provided irrefutable evidence for. Prior to Landers, it was assumed that all aftershocks occurred within a source dimension, or say 50 to 100 miles in this case of this earthquake. But there were aftershocks, as it were, small earthquakes triggered by the main shock at distances of over 600 miles, so in Yellowstone. And so this opened a new chapter in studies of how earthquakes interact with each other. And that story's, we're continuing to explore that. Other large earthquakes, and can we get the next slide, please? Such as the largest strike slip earthquake ever recorded, which, like Landers, was a complex multi-fault rupture. So magnitude 8.6 off the coast of Sumatra. And it, as Politz et al. Showed in their 2012 paper, it triggered earthquakes not just within 500 or 1,000 miles, but all around the globe. It led to an increase in earthquake activity. And so that is something we wouldn't probably have looked for had Landers not shown us that such things were possible. Next slide. So Suhaf also showed this slide, which shows near fault interactions. So what's shown here is a change in the stress field. And the notion is that is due to the Landers earthquake. The notion is that the areas in the warm colors, yellow and red, are moved closer to failure, while those in the blue areas are farther from failure. And you can see the aftershocks, the white dots there, fall in the areas of increased stress. But this earthquake was close to the San Andreas Fault. And so if we look at the next slide, this shows that parts of the fault, in particular, the parts of the fault near San Bernardino and parts of the fault in the Coachella Valley were moved closer to failure, according to this model. And so this we think, and Stein et al. Said that it was something like 10, 20 years, a decade or two closer to failure. Fortunately, no large earthquake has happened on the San Andreas Fault in the intervening decades. But we would like some reassurance that those calculations are correct. And so we search for evidence that these stress changes do impact earthquakes. So if we go to the next slide, a test of whether such effects are real was provided by the aftershocks of the Joshua Tree earthquake. So we're looking at the south end of the Landers rupture. All these dots, the red and blue dots, are small earthquakes. What's shown in the panel at the right is a zoom in on where the stress is favorable in red and where it's unfavorable in blue for further earthquake activity. So we would expect that the aftershocks of the Joshua Tree earthquake would be enhanced where it's red and suppressed where it's blue. Next slide, please. And that's exactly what we see. So what's shown in the left panel is in the areas where we expect more earthquakes to occur. We can see a lot of earthquakes, showing the cumulative number of earthquakes versus time, accumulating rapidly after Joshua Tree and then starting to decay. But then Landers happens and they start becoming much more active. It sort of takes off again. In contrast, in the areas that are blue, the earthquakes after Joshua Tree, the aftershocks are perking along. And then the Landers earthquake happens and they're almost entirely shut off. So this gives us confidence that this stress effect is real and it does affect earthquake probabilities. Next slide, please. So this is an interferogram. So the Landers earthquake, as was mentioned earlier, saw the first use of satellite interferometry using radar images from satellites to study earthquake deformation. So the upper panel shows what's called the fringe pattern due to deformation from the earthquake. Each one of those cycles represents a couple of inches of deformation either towards or away from the satellite. And what's shown in the bottom is a theoretical model of what that ought to look like. It's not identical, but they look quite similar. And these images give us, it's called INSAR, give us a lot of insight into big earthquakes, as shown here, but also to other things that change the shape of the earth, like volcanoes, glaciers, and groundwater withdrawal. So next slide, please. So we can even use these to INSAR to measure the deformation in between earthquakes. So what's shown in the left panel is the north component of horizontal motion of California, measured in millimeters per year. And you can see the deformation across the San Andreas system and elsewhere quite clearly, even though there hasn't been a big earthquake. So we can measure what's called the interseismic or between earthquake deformation. What's shown at the right is the vertical component of deformation. And here we don't see much of a tectonic signal, but we see in the Central Valley a very strong signal due to subsidence due to groundwater depletion. So anyway, this technology was pioneered with the Landers earthquake, but is being used for many other purposes. Next slide, please. All right, this slide was also already shown, and as I mentioned, this should be Chen et al. 2020. But this earthquake occurred in what's called the Eastern California shear zone. It's been something of a theme that large earthquakes recently in Southern California have occurred off the San Andreas fault rather than the main San Andreas fault or faults like the San Jacinto that are closer to it. Next slide, please. So these are just some of the examples of the legacy of the Landers earthquake. There have been too many developments in the decades since to mention them all. So I'll just cover a few that have impacted earthquake science. Perhaps the most important is the development of the internet and related technologies, such as we're using to interact today. And just as for my own anecdote, when the earthquake happened, I was in Mexico City, coming back from a meeting that day. And I didn't find out about the Landers earthquake until 12 hours after it occurred, 12 or more hours after it occurred, because I was traveling and I didn't have a smartphone. That's not something that would happen now. So other developments, machine learning is changing the way we analyze earthquake data and allowing us to squeeze much more information out of the data we collect. Next, forward. So a dramatic example of this is that we're now able to identify often over a factor of 10 more small earthquakes in seismic data than previously. And this is leading into new insights into earthquake behavior. Next. It's getting easier to collect data, whether through remote sensing, cheap sensor technology, next, or distributed acoustic sensing, which is fiber optic cable as virtual seismometers to get very dense measurements, such as shown here. And high performance computing simulations allow us to incorporate realistic geologic complexity to predict the strength of shaking in future scenario earthquakes. So this is very much, even this is a partial list, the science is continuing to advance rapidly. Major earthquakes like Landers can happen at any time, so it's essential to be prepared for them, as we've heard from people who were there. That means primarily efforts in risk reduction, but it also means that we need to be scientifically prepared to collect the data and apply the algorithms that will allow us to better understand earthquakes and to use that understanding to reduce the threat that earthquakes pose. So I'll stop there and take any questions if there's time.
Greg, thank you very much for your overview and your added comments and insights. We'll allow some questions to be added specifically. Oh, yeah, we do have some here. But I would like to, let's just start with a comment. This could be answered by Greg or Sue from Tanya Atwater. We visited the impressive vertical ground breaks in the years just following the earthquake. We tried to revisit it a few years ago. We didn't find any. Are they all degraded, or can we still find any of them out there? Has either of you been to the area and
Okay, I'm embarrassed to admit I have never been to the Landers rupture. Someone else will have to field this question.
Go ahead, Sue.
Hi, Tanya. It's great to see you, although we can't see you. I was there, but not for some years, but I think we have some geologists listening in who may have been there, and I'm aware of, well, I have a colleague at the USGS who's planning to go out there soon to look at scarp degradation. But I'm wondering if one of
Smith has commented that the best ones are on the 29 Palms Marine Base now in the chat.
And hence difficult to access, presumably.
That's right. I wonder if any of our local presenters are aware of in your area still any scarps that you're seeing. Feel free to comment.
No, I haven't seen any.
All right, another question from Carol Burtis from observation, I think on one of your slides, Greg, it says, it seems like the Pacific plate is rotating counterclockwise. Is the North America plate moving at all?
Yeah, so that's a interesting question. So that plot shows relative plate motion, not absolute plate motion. And Tanya Atwater, who's was on earlier, is one of the world's experts on plate motion, and she could tell you that you can represent it either way. Both plates are moving. Tanya, you're welcome to put something in the chat if you feel inspired.
Okay. The question, how can the seismic activity be measured in the ocean versus land?
Well, that's another good question, because some of the important faults in California are offshore. And these are faults that are capable of big earthquakes. It's more challenging, it can be more challenging to deploy instrumentation offshore, but it's not impossible. There are so-called ocean bottom seismometers, including some off the California coast. And this new technology that uses fiber optic cable for monitoring may be particularly helpful in better monitoring earthquakes that occur under the ocean.
Okay, by the way, Gary Rasmussen says that the best place to see a scarp is on the Emerson Fault, south of Bessemer Mine Road. All right, so another question from Eric Morgan. Mr. Barroso, regarding technology, how has drone technology been a factor with respect to its use in detecting earthquakes?
Yeah, so drone technology has not really been used to detect earthquakes, but it has been used quite impressively to map earthquake scarps. And Ramon Aerosmith, who was answering questions earlier, is one of the people who has pioneered that technology for that purpose. I would expect that in the aftermath of future large earthquakes, drones are going to be super important. I think they were used for Ridgecrest. Sue would probably know. Yeah, it's a good question, but it's not so much for detecting earthquakes as for mapping their surface manifestation.
I know that helicopters have been a quick and urgent need for geologists after earthquakes like this. So drones are providing new technology to maybe a lot cheaper than getting a helicopter immediately following an earthquake. We have, and speaking of technology, Mark Legg asked a question, I'll answer. It's Mark Hughes asked, with the latest communication tech, cell phones, et cetera, is it still important to avoid tying up telephone lines following a major earthquake? The answer is yes. So the bandwidth of our cell phone network as well as our landline network is still not meant to handle everyone trying to call each other and check on each other. It's really a much lower percentage of lines that can be used at any one time. So the recommendation is to, for one, if you're going to try to reach someone, try texting first. Just find out, are you okay? I'm okay. It doesn't take that long you're not texting very long texts. It's that very simple check-in. If you're not reaching them and you're very concerned, you might need to try to call someone. But that's why we always recommend having an out-of-state contact, as the long distance lines may be available sooner than the local lines, which are limited to first responders trying to really deal with the response, and so are not necessarily open. So also cell phone towers may be damaged. Your reliance on cell phones may not be very helpful because the connectivity overall may be down. We also have a question kind of continuing in technology from Eric Morgan for Gino Prudhomme regarding other whether amateur radio and local ham radio operators has been further integrated into your community's emergency response. I know you commented on that. You could say anything more about how it's integrated into your response, Gino?
You know, in our region, we have a little bit difficult there, because we have what's called a SCEC, which has, we have, 4 different buildings from Point Palms, Yucca Valley, Desert Hot Springs, and Palm Springs. Sorry, my video's not going. And it's hard to, we have disruption from different mountains and stuff. So that's some of the things we're trying to work out. But yes, we've asked each leadership to be able to get a ham radio license to be able to work together a plan for their local area. So 29 Palms, we asked them to have a ham radio and do their preparedness drills within their community. Yucca Valley, we've got 2 congregations here. Desert Hot Springs 1, and then there's 2 down in Palm Springs. So it's hard to do it as a whole, but we're asking everybody individually within those congregations to devise a plan that works for them without all the different obstacles in the way. But it's a work in progress. We've come a long way. We have ham radio emergency kits in each of our buildings that are, we have a Pelican case, and then we've got ones that also are mobile units. So we've gone that far to be able to do that, but it's a work in progress. And we've got several ham radio operators now. So we're continuing to improve that each and every day.
Thank you, Gino. Okay, so we're wrapping things up. Looking at other comments in the chat. And I'll advise everybody look at links that are being put into the chat with articles and photos and from the California Geological Survey. Also the direct link to the Landers earthquake, did you feel it page? A lot of great content being added there. Thank you for all the participants. And looking back at any other questions here. Yeah, Tim Dawson's mentioned again how many of much of the Landers rupture was on the Marine Corps base and not accessible to the public. And comment from Richard Dancy, encouraging those in San Bernardino County who are ham radio operators to join with the emergency communication services to provide for your various communities. And Richard, if there's any link you want to add in the chat about that, please feel free for people to find out about that. And Gino, or rather David, if more, you've asked a question for Gino's contact information, you may be able to chat him directly in the chat to request that, or you can email the address shown on your screen and we'll get that to you rather than putting it out publicly. scecinfo@usc.edu. I guess we're not sharing, but I'll show you again, is for everybody, where you can ask any follow-up questions for today's webinar. We will be able to connect you with the presenters or others. So please don't hesitate to email us there. And we have, again, a number of comments in the chat, the contact information for the communication services from Richard Dancy. Thank you for that. And also be sure to look at those links for some of the imagery, photos, and research papers that have come out of the earthquake. We are going to have the recording of this. Sorry again for the technical issues at the beginning. Hopefully it seems to have gotten better here. That will be available by next week at the same place where you registered at scec.org/webinar/Landers30. And we'll probably have the PDF of the presentation as well there. And comments and thanks to the presenters from Eric Morgan, who's a second-year emergency EMER grad student. Not sure what that stands for. And thought this was very relevant. Thank you for that. Any other comments, Sue or Greg, to complete today's webinar?
I'd just like to thank Mark and Gabby again for hosting this, and to the presenters. It was fascinating to hear the local perspective, what people went through. And if seismologists are ever guilty of saying, oh, it was a remote area, we shouldn't do that. Earthquakes impact people, and some of them impact more people, but there were still people in the desert communities, people in Ridgecrest, where I have long family ties, and we shouldn't ever forget that. So thank you.
I'd like to also thank our local panelists for their their presentation, their comments. Also, Chief Topolesky for your perspectives, to Sue and to Greg for your presentations, and for all of you for attending. We will go ahead and conclude. Thank you again for joining. Have a good rest of your evening.
Thanks, everybody.